Okay, let's look at the limit comparison test. All right, so we are basically comparing the summation with an and the summation with bn, and the an and bn are non-negative terms. All right, so if you have a series with bn converges, and if you take the limit of the ratio between an and bn turns out to be a finite number, then summation with an also converges. So an and bn both converges, right? And second version is, let's say bn summation with bn diverges, right? Then the limit of the ratio between an and bn is greater than 0. Then summation with an also diverges, right? So an and bn diverges together, right? So let's apply this limit comparison test to determine if this following series converges or diverges, right? So basically we have this kind of scary looking summation here, but this guy is our an, right? So we are interested in this guy, right? But since this is too complicated, we want something simpler. So we're gonna try to come up with something to compare with. So let's call this guy bn, right? So the way you come up with bn is kind of get rid of all the terms that doesn't really affect behavior. So looking for the leading term, which is going to be square root of n cubed. So on top, this guy is going to be our leading term, right? On the bottom, you have a choice between n squared and the sine. Right, sine function doesn't get very big. Biggest it can be is 1. So you can, it's negligible. So you can see that the leading term is going to be this guy right there, right? So we can just erase those guys and just use the leading terms on top and bottom. So you have square root of n cubed divided by n squared, right? But this is can be simplified. So this is equivalent to n to the 3/2 power because of the square root, and divide by n squared, right? Then simplify that. 2 minus 3/2 is 1/2, so it's going to be 1 over n to the 1/2 power, right? So let's think about the summation series with bn. So you have n goes from 1 to infinity, right? Bn is 1 over n to the 1/2 power, right? But this guy, we know that this is a p series with p equals 1/2, right? If p is less than or equal to 1, we have a divergent p series, right? So we already know that the summation with bn will diverge, right? So we are looking at the bottom guy here. So we are trying to apply the second one to this problem, right? So we're going to have to evaluate the limit of an over bn. So let's do that. So you have a limit as n approaches infinity, right? An in this case is just complicated stuff. So square root of n cubed plus 5n minus 1 over n squared minus sine of n cubed, right? Then we have to divide by bn. So it's divide by 1 over n to the 1/2 power is multiply by n to the 1/2 power, right? All right, to simplify this, I'm going to just divide top and bottom by n squared. So it's going to be divide top and bottom by n squared. just to simplify it, right? So this way, you see that you're going to get this. Here's the limit as n approaches infinity, right? Try to simplify as much as we can. All right, so you have an n squared divided by n squared, so that's going to give you 1, right? And here, we can't really do too much, so I'm going to just write it down. So negative sine of n cubed divided by n squared. All right, so then let's see, we can cancel. There's n to the 1/2 power. Then you have n squared on the bottom. So you can cancel this guy, and you have 2 minus 1/2 would be 3/2, right? So you're dividing by n to the 3/2 power. So if you put that inside the square root, so it's equivalent to dividing by n cubed, right? So put that everything inside the square root, right? So n cubed divided by n cubed is going to give you 1, right? And 5n divided by n cubed would be 5 over, one of the n cancel out, so n squared, right? A negative 1 divided by n cubed is negative 1 over n cubed, right? All right, this way we can evaluate it. You can see that here. 5, n is going to go to infinity, so 5 over n squared, so that's going to go to 0. And the same way, 1 divided by n cubed is going to go to 0 as well, right? Here, on top is at most 1, and the bottom is getting larger and larger again, so this guy is going to go to 0 as well, right? So you can see that this is going to actually boil down to square root of 1, which is 1 over 1. So the limit is 1, right? Which is greater than 0, right? So it satisfies this condition. So Bn diverges. So we got that, right? Also, the limit of An over Bn is greater than 0. We also got that. So therefore, the conclusion is An also diverges. So the answer is this guy diverges. Right? So that's how you apply limit comparison test. Right? I hope that this was clear.